So, hello everyone from my side. I'd like to start with a few words about myself. So, I actually started my academic research activities in music information retrieval. So, I did my bachelor and diploma thesis in music information retrieval. So, for me, this is a bit like coming home. When I left off, non-negative matrix factorization was a thing. So I saw that on I saw NMF on your slides. Is that still?
Es gibt a slide where I said why it's not.
Okay. No. I know that now everything is CNN. So, but I just wondered if that was still a thing because I left 10 years ago in that field. Okay. All right. So my task is, or what I tried to do in this talk now is to build on the introduction that Professor Ferscher has given in this morning, building on this set of awareness levels that he has introduced, and he has already drawn some analogies to the applications in music, but to build more on very specific use cases and applications that we are building at the moment, try and give my opinion, my perception, how these could be applied towards interactive music technologies. And I would like to formulate that as an invitation for anyone here who feels activated by what he will be seeing here about the ideas, and to contact me, and I would be very happy to get some of these ideas realized with your help. All right, so we had basically these 5 levels of awareness: spatial awareness, activity awareness, intentional awareness, and attention awareness, and competence awareness. The formulation this morning were a bit different, but the what is behind these topics very much aligns with what Professor Ferscher has described this morning. And in my opinion, there's a corresponding scale to what we are doing on the music technology side. And I would like to create that scale and bridge these scales in this talk today. So I will try to start with the topic of spatial awareness. So for me, spatial awareness for our applications is the fundamental knowledge that we need to build any kind of service. So most of our applications are in industrial support systems, industrial assistance systems. So our task is to use sensors as best as possible to describe the situation, the spatial environment, and the position of the user and the relation of the user to objects in space in these in situations. So we have seen that video this morning. So basically what we're doing here is we just use a RGBD camera to create a 3D environment, and so that we can model our environment. So I will skip that. What I want to show here is one of the applications that we have been doing in this. Is this starting automatically, or do I have to start? I have to start, okay. So what we did here is that we built such an environment, and we were able to localize ourselves in that environment and to provide a navigation support with augmented reality applications. So here you see the RGB image input and already the augmented assistance. Here you see the spatial model that we have built, and how that position, just with visual features, how this position inside that model is established, and how then we can, at the correct positions, render these interactive guidelines, visual guidelines that help the person to navigate through a complex environment. So this has lots of industrial applications, guiding people to places where they're supposed to provide to execute maintenance tasks and etc. Guiding people to places where there are hundreds of machines and they need to go to exactly that machine that they are supposed to repair. So here, the summary of use cases that we are currently doing is we use spatial awareness for navigation tasks and for real-world alignment. So if we know exactly where a person is standing, what his perspective is, then we can use that information to perspectively or correctly overlay information onto objects into the environment with augmented reality. So this is a really fundamental prerequisite for our assistance systems. And in my opinion, the corresponding field in music technology is music information retrieval, because it provides the same fundamental knowledge. Without music information retrieval and the information which is being taken from all the data which is created from that, this is the basis for any other high-level application which is being created. So that was basically my further interpretation of music information retrieval. Is you go from low-level descriptions of pitch, keys, and chords, rhythm, to track separation, to genre, emotion, recommender systems. I think we have heard that several times today, so I will go a bit quickly over that. So the next for us is activity awareness. So we try to monitor the activity of people in industrial cases to support them in the execution of their task. I have one example. I could have chosen other ones. So what we see here is a person, it's a hydraulic press, and the person is supposed to fill big metal pins into these holes, and he has a paper sheet, and he's counting on the paper sheet and with his feet on these 250 holes where he has to put these pins, and if he has made a mistake, then a piece of several €100,000 is broken. So we are trying to use augmented reality here to guide the person to really put these pins into the correct places without him having to count these individual holes. And so this is basically observing the activity of a person and supporting him in the execution of a task, evaluating if a person is doing a task correctly. The corresponding thing on the music technology side is, for me, something that I was surprised has not been mentioned today, is the actual rehearsal musical training of individuals. So here you could analyze the technical execution of a piece by analyzing just movement, and thus to evaluate, has this been done correctly, or has there been a mistake? So I'm explicitly not talking about artistic expression here. I'm just talking about the correct technical execution. Because, as I will say later, the differentiation between artistic expression and correct technical execution is, I think, one of the biggest challenges that we would have to face in doing such a system. So for me, such an application would be for people, supporting them in their rehearsal, in their training, just to have a system which tells them, okay, so I have learned piano for 13 years, so I know that how the hand posture has to be, how the elbow posture has to be. But if you could use such a system, perhaps even with actuators on the body, you could remind people, okay, in that situation, if you put your elbow higher up, then it's easier to do the scale and that. And so these are things that tutors have to do all the time. It's like my piano teacher was always standing behind me and pushing my elbow to the side because I was dropping it, and you become lazy and you drop your elbows, and then it doesn't work anymore. So the third thing is intention awareness, and what I mean with that is implicit and explicit interaction. So we try to include in our systems, because as Professor Fesch has mentioned, we are not using keyboards, we are not using mouses. We have to invent intuitive modes of interaction. So there is an application where we use gesture analysis with such a head-worn augmented reality assistance system. So you can see here that in an industrial environment, hands are recognized, and the person is able to take screenshots of meters or of any there's the frontward camera, and he's just able to trigger camera screenshots as he goes, so which automatically document the workflow that he's doing. And so that's one example of how we create intuitive interaction modalities. The correspondence for me is creating interactive music technologies. So we have heard that before today as well. So this ranges from creating interaction in gamification, creating, for me, the biggest thing of interaction is engagement. Engagement in the music perception in media, but also in events. So how can I improve the experience of each individual in the audience by making this event interactive, and how he can make it for a very how he can individualize his own perception of this event, to make him from a passive member in the audience into an active part of a social event that he is contributing to himself. And here are also these examples in the music creation, so from music perception towards music creation. I think interaction is a very important part in this whole thing of music technologies, and where we, with our competencies with users, with sensors and actuators, I think have very high competencies in the realization. The next level is attention awareness. So this is my specific domain that I've been working on. And so we have two different fields. One is the spatial visual attention analysis. So there's a video which, unfortunately, in the test we noticed that doesn't run here. So what we did is we built on that spatial localization to map gaze in 3D environments. So what we are able to really map gaze and visual perception in 3D environments. And the other thing is the analysis of cognitive load. So we, besides the what has been mentioned before, the physiological senses of valence and arousal, we are measuring cognitive load from pupil dilation, which is highly correlated to these physiological senses. So here's an example of a training station from a ship in a simulator. Here's an oil platform, and the task is to collect these people in that cage on the front of that deck, and there's a very high and energetic sea waves are going on, and you can see that there are high waves going across the shield. The ship is getting completely out of control. And here with our measurements, you can see that exactly now, as the ship is getting out of control, that this cognitive load and stress level of that person is going through the roof. So now he's sort of almost colliding with the oil platform. He's getting the ship back under control. He's able to turn it around. And as soon as he's out of the risk zone, he notices, okay, I'm getting away from it, then the level drops immediately again. And this is repeated 3 times. So let's wait for the second one. So you believe me that we won't wait for the third one. So now he's sort of back into calm waters. And yes, so very soon there will be the next big wave. Yes, so now he's again out of control, spinning towards the platform, and again our measurement of cognitive load and stress levels goes through the roof. So we see that the algorithms that we developed here will really work nicely to indicate cognitive load levels. What is the analogy? And I was really happy that I just had the talk before me about emotion and how this is how music and emotion is connected together, so I don't have to argue that anymore. I can just build on the information that you'd gotten just before. So yes, there is emotion in the performance, there's emotion in the perception of music, and of course there's then the question, how does this neurologically and psychologically impact, and all of these questions are very interesting. I think that the with our approaches, perhaps together with something towards the galvanic skin response and valence and arousal. I think there's very high opportunities to do something in that direction. And the last thing is competence awareness. So that is something that we're weiß nicht. Yes, thanks. So we are currently engaged in a project where everything comes together. So we are in a project about competence-based training and pilot education. So we combine multiple sensors, mobile eye tracking, cognitive load analysis, workflow monitoring to analyze the competence levels of trainees in pilot training. And so we monitor visual perception and gaze and cognitive load in the interaction in the cockpit. And what we do is in the next step, then we monitor the perception, visual attention, cognitive load, automation, and interaction analysis to really deduce over time how the competence of the individual person is developing over time. And I think that this can be directly applied again to training of professional musicians. So that's my last image, which I think is really really expressive and impressive. You see here how the instructor tries to get the emotion, get the best out of the trainee. And I think now comes the artistic expression into play that I sort of took out of the challenge before, but I think this now, in that context, this really has to come here to describe not only the technical execution of the piece being played, but also the cognitive load level. So is the automation level reduced so far in the execution of the playing that I can concentrate on the artistic expression? I think this is something which would be a really, really interesting question in the support of training of professional musicians. So these are the ideas that came to me looking at our work, and perhaps these are seeds that somewhere grow in different brains to come up with something fruitful. And I would be happy if someone comes to me and says, yes, that's what I want to do. All right, thank you very much.